velocity time graph is the heading, right? Okay, people, now here velocity time graph. Now in this case, here very few theories available in this part. Now suppose here this way, a particle is moving along a line, right? Now we take the records these. We measure the velocity v of the particle with time, and we keep the record like this. The time t here, velocity v. From time to time, we measure the velocity of the particle. Then we have some readings. For the time this, velocity is this much. For the time this, velocity is this much. This way, some readings we have. Okay. Now what we do, taking these readings, we sketch a graph this way. We sketch a graph. This vertical axis is velocity axis. Horizontal axis is time axis, like this. Okay. At the time this, velocity we have this much. Then that two readings we can mark by a point like this. The next one also we can mark like this. Next one we can mark like this. Suppose this way we get set of points after plotting them on the graph. Now we can join them by a smooth curve like this. Right? This is people known as what? The velocity time graph of the motion of this particle. So therefore, velocity time graph means how the velocity varies with the time. That is explained by the velocity time graph. Understand? Right. Now, secondly, you can see here, when we go to write along this time axis, you can see this height always gives what? Velocity. You can see when we move along the right time axis to the right, time increasing, no? With the time elapses, you know, the height increasing mean people, velocity increasing. You know, with the time, velocity increasing mean, definitely for this, the particle should have what? An acceleration. You know, in order to have an acceleration, definitely a certain external force should act on the particle. Therefore, this particle, if its Vt graph is of this shape, definitely the particle should have an acceleration. In order to have an acceleration, a force should act on this particle in the direction of motion. So therefore, remember people, as the time increases, in this way, if the velocity also increasing, remember that motion indicate what? Accelerating motion. Understand? Accelerating motion. So with the time, if the velocity of the particle decreases, how should be the Vt graph? With the time increases means, what people? Time increases means we move along the time axis to right. That occasion, the velocity of the graph decreasing, then the Vt graph should be of this type. Correct, no? Here, once we move to right along the time axis, this height decreasing here. Understand? Okay, so therefore, just looking at the Vt graph, now you can understand whether the motion has acceleration or retardation. So if the graph is in the increasing direction, definitely the motion has acceleration. Decreasing way, it is having a retardation. What is meant by retardation? Rate of decrease in the velocity. What is meant by that? Rate means what? In 1 second, decrease of the velocity is the rate. So in order to have a retardation, definitely the object should be acted a force in what direction? In the opposite direction of motion. That means really on this particle, it is now moving rightward, no? In the opposite direction, this direction, if an external force acts on the particle, because of the action of this force, the particle will move with what? Retardation. That means decrease in its velocity, given the Vt graph like this. Okay. So therefore, basically, By observing the shape of the VT graph, now you can understand whether the motion has acceleration or retardation. Okay, right. Now suppose people, next thing, right, this lesson is very easy lesson. Every question is coming to the applied paper, right? In the part B paper, part B, question number 11. Question number 11, there are two questions, A, B. First question is coming by the velocity time graph. Part B coming by the relative velocity, right? Now, you know, this graph is increasing graph, velocity increasing. Therefore, this motion should have what? Acceleration. Okay, people now think this. Suppose we have a certain time of the motion of the particle, suppose the time is t naught. At this moment t naught, we said what the particle is moving with certain acceleration, no? If we want to measure the acceleration at the time t naught while the particle is moving, this is how we measure that. From the time t naught, draw vertical line to meet the VT graph like this. That line meets the VT graph here. Now at that point, construct a tangent to the VT graph. What is meant by tangent? A line that touches the graph at that point like this. This is a tangent. Okay, now that tangent is a line like this. That line, people, now makes an angle here. On the right of the time axis, this angle. Measure this angle alpha. Right? We can find tan of this angle alpha, tan alpha. Right? That tan alpha is, people, at the time t naught, the acceleration of the moving particle. Okay? Tan alpha is the acceleration. We can prove this really, but proof, of course, not that much important. Understand this way. Tan alpha is the acceleration of the particle at that moment. What is meant by acceleration? At the moment time t naught, the rate of increase in the velocity. Definition of the acceleration is what? In 1 second, what the increment in velocity is the acceleration. Then here at time t naught, the velocity of the particle increases at the rate what? Tan alpha. Okay. Now, you know, this graph is what? Having a retardation. Why? Because, you know, with the time, the graph decreases. Velocity decreases with the time. With the time, velocity decreases, mean, people, that is because of the retardation. Now, in this case, if you need to measure the retardation at certain time, suppose t naught again, I'll take t1 here. At that t1, construct a tangent like this. And now, measure the angle this tangent makes with the left of the time axis, this one, right? If this angle is beta, then tan beta gives us what? Retardation of the particle at time t1. Retardation of the particle at time t1. This is what, people, you first understand. Okay? Right, no? Right. Then we'll write a brief note like this. Write down like this. Velocity time graph is heading, and then write down one sentence like this. Write down the variation of the velocity. The variation of the velocity of a moving object. The variation of the velocity of a moving object. The variation of the velocity of a moving object with time can be shown by a graph. Can be shown by a graph with y-axis as velocity, axis, and x-axis as time axis. This graph is called as velocity time graph. of the motion of the object, of the motion of the object, right. Okay, now first one, this one, motion with an acceleration. Motion with an acceleration. Number one, draw this one, write in this. Number one, motion with an acceleration is number one, this. Number two, this. Motion with a retardation. Right, first one, this. Small graphs, small graphs. Right. Then we can write here acceleration at time t naught. Acceleration at time t naught is given by tan alpha. Here, retardation at time t1 tan beta. Draw these both graphs.